Okay, recorded, no problem. I have one more question because Kinga said to me that today I will have a meeting with students, with some students. Yes.
Yes. Yes.
Okay. Great. Great. Because the principle, the base of my presentation is very similar that, and I show you last time, very long time ago.
Okay,
before strange times. Okay, great.
Okay, I think we can start our meeting. Good morning, everyone. Today we are continuing pilot teaching within the BIOART project.
Okay.
Okay, I remind to all participants of the meeting, enter your full name and organization in the chat, please. Today is the third day of our meeting. According to the program, we have two lectures too. The first one will be led Szymon Gądek. He's from Krakow University of Technology, Poland.
Yes.
After a few minutes, the lecture will begin. And now turn on your cameras to take a screenshot of our meeting today. Thank you.
Okay.
Будь ласка, увімкніть свої камери для скріншота сьогоднішнього дня. Прошу.
Okay. I must close some windows, but I will start now. Okay. Can I share my screen? Yes, I can share my screen. It's good. Hello, everybody. My name is Szymon Gądek. Today I will...
One moment, please, Szymon. Okay. One moment, please.
Okay, okay.
Okay, green screen. Sorry.
No problem.
I can do screenshots while I don't know why. Кто-нибудь сделайте скриншот, потом мне пришлете, если вам не сложно.
Just use print screen to do it.
Okay. Okay, Shimon, start please.
Okay, hello everybody. My name is Szymon, and I'm from Krakow University of Technology, and I want to show you some presentation about I will share it. Yes, about fundamentals of 3D printing, biomedical and biomedical application. The base of my presentation, I think that you know a lot of things from this presentation, because this is principle of the 3D printing. But I think that it will be very good review to this topic. I think that everybody know what is the basic of the 3D printing. Of course, this is additive manufacturing, and we must make our products layer by layer. What kind of material we can use? Almost every kind of material we can use in this technology, and because we print, of course, the most popular the print techniques is based on made something from polymers, because I think it's much easier than different technologies. But also we can print from powder metals, we can print from ceramics, we can print from, of course, liquid resin, but all the methods are connected but one principle, that we made something layer by layer. Of course, the 3D printing is raised from needs to make something very fast, to make something very rapidly. And here we see some definition about rapid prototyping, and of course this technique was almost in 100% was made to do something rapidly. Of course, that you know that 3D printing is not very fast technique to make something, but in most cases, this is only technique that we can use to make some special things. Yeah. Of course, we have different kind of rapid prototyping. We have rapid modeling. We have rapid manufacturing. We have also rapid tooling. And here we have types of additive methods. Stereolithography, this is the oldest method. We have also laminate object manufacturing, and these techniques is now, I think that this technique is abandoned, because I will show the principle of the technique to you. But the basics of these techniques are very similar to all kind of rapid to 3D printing, but we waste a lot of material in these techniques. That's why I think the people abandoned of this technique to make something in different way. Of course, we have also fused deposition modeling, and I think this is most popular technique, because the different name of this technique is fused filament fabrication, but the FDM is most popular name. Of course, it was patented by Stratasys company, but I will talk about this later. And I think this is very popular technique because the machines are cheap, the material are cheap, and the prints are the prints are quite good, and also it's easy to do. Because in different kind of TIC, for example, when we want to do something from resin, our processing is more complicated than in FDM. Of course, we have also jetting modeling, and we have also binder jetting. We have also a whole of bunch of power bed fusion techniques, but in this technique, these techniques are very, 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 these techniques needs a lot of cost because we need very expensive machines. Because in these machines we must use a very high voltage laser. We need also very pure powder of metal powder to print something. And this techniques is reserved to special things. Okay, I said that SLA is the oldest technique, and the basics. Of course, I'm pretty sure that you know all the basics of this method because you have something about 3D printing. And these techniques it's based on about making something with liquid resin. On this animation that you can see, we use a tank and our bed. This plate is called bed. Our bed it go from top to down, and we use laser. Laser change our substance, change our resin from liquid to solid because we use ultraviolet laser. And this resin can change the structure, the change of structure by this laser. And you can make something like this. You see on the screen. But this technique, basically on this method, it's very slow because we must hardening point by point all our structure. Historical, it's the base of this method was written by Hideo Kodama in 1981, and he writes a paper about this technique. But the father of 3D printing, we can call this guy. This is Charles Chuck W. Hull, and he patented this technique in 1986. And we can say that this is starting of 3D printing. This date is starting of 3D printing because they start to do something 3D from liquid resin. This is basics of 3D printing. Of course, now we can use the basics of the method is the same, but we can use different kind of devices. I show you that in the previous method, our bed goes from top to down, but we also can use different kind of machines. That bed will go from bottom to top. And here we have, of course, our laser, and we must use mirror to change the direction of laser beam. But the principles are the same. In this method, for example, here you have a laser beam, but here you have ultraviolet projector, and you change structure of material on whole plate. And this technique is faster, much faster than previous one. And not that fast like here, because here is 7 times speed, like you can see. Maybe on your screen is very small, but I see here that this animation is this video is increased speeding 7 times. But it's much faster than these techniques, laser SLA. But now we have less expensive machines, MSLA. Here we don't have any projector. We have only ultraviolet light, but between our chamber and this light, we have screen, 2K screen, and we black out some spots that we want. We don't want to change the structure, and the rest of screen, the rest of points that we want to change the structure, we change we change the we want to hardening. It's transparent, and this technique is much faster. Similar, the speed is similar like in this technique, but we don't need any projector. We don't need any different kind of devices, but we use only screen and ultraviolet lamp, and the device is much cheaper than in this case. And of course, the quality is it's not that good like in the first or even in the second case, but still it's very good. When you compare it to FDM, it's much better. Here you have some comparing between SLA and DLP or MSLA, and you see that in here the surface is much smoother than in this case, but the speed is much faster, because in this case we hardening all surface at once. No, in here we do it point by point. Of course, we have of course advantages and disadvantages of this technique. Advantages is high dimensional accuracy, the complex structure of prototype of and fine size, in particular in the international structure. Excellent surface. The surface it's excellent when you compare it to different kind of techniques, of course. A wide range of materials. We can use thermoplastics, we can use elastomers, of course, elasto-optical properties of some materials, and easy machining post-processing. But we must use liquid resin, and in some cases these resin are toxic, and we need to use ventilation. We need to use open space, for example, because it's not good for your health. And that's why it's better to have close to use this device in or big rooms or with good ventilation, or even it's good to open the window. And of course, you need to clean the model from resin by acetone or isopropanol, and you need to hardening this prints after print, because the heart of this prints it's not quite good. And after that, you must hardening used to ultraviolet lamps, of course, and or in some cases people put it on these prints on sunshine, because in some cases sun can hardening these prints. But faster method is used to ultraviolet lamps, of course. And here you have some examples of prints, of course, and on the end I will show you some more examples in biomedical. Here, for example, you have some jewelry and very good. Oh, you get very good quality of prints, and you can make some very the materials when you need some very good smooth of surface. Fun facts: in 2013, Lady Gaga wore the 3D printed parametric subtle dress. And this dress is prints from resin, but also they print the head of Lady Gaga. This is a kind of some fun fact. Okay, I tell you that I told you that this technique is forgotten technique because it's patent in 1988. This is very old technique of 3D printing, and the device, as you can see, is very big. But in this, on this technique, you can make some materials from paper, some plastic, or even some metal. And the principle is very easy. Here you have one roll of paper. I will tell some principles on the basic on paper print, but in all the materials, the principle is the same. Here you have paper roll. Here you have laser, and you have cut the shape, the one layer shape. Next, the bed goes down. The roll change the roll change it, and the part of the paper change it, and you cut the second layer. This paper is connected with special glue. It have special glue itself. And here we have a roller. And this roller is heating up the material. The glue is melting down and connect each layer. And next, we have next part of paper, laser, and we can get very big prints. And like you can see, this printer is huge, yeah. When you compare to FDM printer, or when you compare to different kind of prints, this is a very huge printer, and you can get very huge prints. And on this video, as you can see, the material made from metal parts. Here you have some metal no plates, but metal foil, and you connect each layers by ultrasonic oscillation. You have here ultrasonic welding, and of course you have some kind of grinding machine, and you must in here it was laser, and here you must use a grinding machine, and you can get some metal parts. Of course, here you can use different kind of materials. You can change materials when you print it. But I told you, you see the quality of this video. This is very old video because this is very old technique, and I think many people forgot about this technique. Why? Because we have a lot of waste. Of course, we can produce of mock-ups and prototypes. We can low price of the devices. Yes, the prices of devices is lower than in case, for example, somebody drives his car. But okay, doesn't matter. I see that on camera that somebody turn on the camera, and I see that he goes somewhere by his car. Okay, it doesn't matter. When you listen me, it's good. Okay, the price of this kind of machines now, of course, I'm not pretty sure that you can buy it, but the price was lower than in another cases, for example, because on the basics the price was very high. FDM, of course, because the statuses had the patent of these techniques, but now the cost is lower. Of course, you can machining very easy these prints after printing, but this print was made in most cases from the paper. Yeah, you can painting. It wasn't problem. But for example, it was very hard to remove supports in this case. But what was nice, because it was self-supporting technique, because on the end you remove the support, but when you close the support inside the print, it was very hard to remove. Yeah. Now, for example, when you print something from powder, you put some special hose to remove the powder from inside. But the powder is powder. You can remove it very easy. In this case, when you have hard structure, paper structure, it's very hard to remove. Okay, but this technique was very good. For example, to casting, to do some modeling, some very big, very huge model. Here you can, for example, see scale 1:1 some parts of engine, and it was very good in this technique. Okay, my favorite FDM, fused deposition modeling. They use another name, fused filament fabrication. Why they use this name? Because it was patent. And I'm pretty sure that you know this technique quite well. You can get nice prints after the techniques. But fused deposition modeling, it's not only print something from polymers. You can print something from concrete. You can print something from clay or different kind of material. The basics is all the same. I told you that it was invented by Scott Crump in the late 18th, and they get patent on that. But in 2009, that FDM patent expired, and what came next is often considering the breadth of mainstream consume 3D printing. When you see the history of 3D printing, you see that from 2009 on the market, you can get some very cheap printer. And now, but it was open printer, cheap open printer. But now, from this February, the last patent on chamber printer collapsed, but the patent ends. Okay, the patent ends in February, and I think in this year we will get some cheap chamber printer on the market. I'm pretty sure. The Stratasys is very good producer of printer, but the printer are very expensive. The printer is very expensive, and also filaments are very expensive, because in this technique, in most cases, you use filaments, yeah, polymers materials, and in this device you must use exactly the producer filaments. And the cost of this kind of filaments, when you compare it to the normal filaments that you can buy on the market, it's 10 times more. But this is the same filament. Of course, they said, okay, we have better quality. We have better quality. We check all our filaments. But I'm pretty sure that on market, you can find very good quality of filaments in the same material, the same I forgot the word, but it doesn't matter. The same quality of materials. We stay on this, but more cheaper. The principles of this method that I'm pretty sure that you know. We put some material in most cases plastics materials. Inside the nozzle, we're heating up the material. We get some very small drop of liquid material, and we put it on the bed, layer by layer, in this way. Okay, on this video you can see also some kind of technique that we can use welding, but it's not true, not 100% true. Of course, you can use it's called the techniques. It's called low voltage techniques to cast to weld something, and you can use it to 3D printing, but the quality of this material is not very good. But in FDM, of course, we have advantages and disadvantages, and the advantages, I think that you know all the advantages of this method because it's well known. But disadvantages: hygroscopic material, lower endurance of the models and the layer boundaries, and difficult removal of supporting materials from gaps or holes. In some cases, it's very difficult to remove. You can use different kind of supporting. Yeah, it's more popular now. Tree supporting or different kind of supporting, smart supporting. And you have low quality of inclined walls, stepped effect. But now in modern times, it's this stepped effect is less than a few years ago, because the devices are much better than a few years ago. In this technique, of course, here you can use very different kind of post-processing. For example, when you put prints to the salt, but you must put it to the container with the salt, with very low, very small particle of salt. You must grinding before, and when you're heating up to 200 degrees of Celsius, you get harder. The structure will be harder. For example, and the properties of this material of the prints will be better, but you must be careful. It's only when you use 100% of infilling, because you see here we have some kind of 20%. Yes, I think 20% of infilling. In this method, when you want to harden in the salt or in different kind of material, you must have 100% of infilling, and you can hardening your prints after printing. Of course, you can on the market you have different kind of methods. You have different kind of materials. Yeah, special PLA with some additive to increase the properties of the samples. Here you have some applications. FDM. This is engine, electrical engine, but not all parts are printed. Only shelled and some parts inside. Here we have a clock. Here we have, of course, car. But you see the layer is very high. There are some bookmarks, of course. Here you have something you can use it in medicine, some kind of authors, but you can print some different kind of things. Yeah, some more samples here. Yeah, I love 3D printing. I love FDM. That's why I think that you can print almost everything. Here we have some jetting modeling principle of this 3D printing. Here you must use some resin, and here you use you can use two different kind of material. building material, and in more cases support material, but you can use different color of material in some cases, because the color is very light. That's why it's sometimes you must paint them prints after printing. And here also you use ultraviolet lights to print some elements. And here you also have advantages and disadvantages of these methods. Of course, here you have disadvantages very similar to the first technique, to OSLA, because here you have also connect with toxic resin. That's why you must have good ventilation. The printer is much more expensive than in previously method, but the surface of our prints are better, much better. Here you get some oh, sorry, some mistakes we have here. Here I have some application of this method. Second method is binder. Next method is binder jetting, and in this technique you use powder. You can use ceramic powder, or you can use also metal powder. And here you have some jets that have glue, and you glue together the parts of materials. And next, because you must have also two chambers, yeah, one is go up and the second one is go down. Okay, on this picture it's a mistake, because this arrow must go down and this arrow go no, this arrow must go down, yes, and this arrow must go up. In this chamber you print your things, and here you have inkjet printed head, and you, like in normal 2D printer, you inject the glue on the surface of the powder. Next, this table go down, this table go up, and you put some materials from one container to another. And the same situation, you use print head, and you can connect the particles of layers and particles on one layer. And in these techniques, in some cases you don't need support, but it depends what you want to print. In more cases, they use this technique to print some things to casting or something like that. But also they print this. They use these techniques to print something with hydroxyapatite. This is a substance that is very it's biocompatible to organisms, and they use this technique to print some artificial bones, for example. But this technique is very what next? And the advantage is that you can use different kind of color of glue. That's why you can get some colorful prints. But after printing, you must do some post processing because the hardening of this print is not high. That's why you must use infiltration, some kind of infiltration, and you can get very hard prints. Here you have some kind of application. You have here some kind of application. I told you that you can use it to print some metal parts and some ceramics parts. Also, you can use it to print things from polymers. But in most cases, it's ceramics or metal. and you can see on this slide the application of this method and the structure, the surface, likes the how it looks surface. The last techniques, yes, the last techniques is one of the power bed fusion technique. The principle is very easy to privilege technique, but here you must use very strong laser, and also you have two beds. You have here powder of metal. You put some powder in the first chamber. You connect the particles by the laser, and you have two techniques, SLS and SLM. Sorry, SLS is selective laser sintering, and SLM is selective laser melting. And the difference is the power of the laser in most cases. And also you can use this technique to make something from not only from the metal powder, but also from plastics and even from something from glass. The principle is the same like previously. It's the same method. Here you have some different kind of method. It's called lens, laser engineering net shaping, and here you have 4 nozzle, and you put the powder through this nozzle, and here you have laser. In most cases, it's 2 laser beam. They cross in one point, and in this point, the powder is melted down. You must put all the time the powder through the nozzle, and when the powders flew to the crossing laser beam, it's melted down and it's connect with the surface, the previously safe surface. This technique is used to put some layers on some materials. But all these power bed fusion techniques are very expensive, because you need first very expensive material. In most cases, it is powder of metal, and this powder must be very small. Particles must be very small, and it must the shape must be rounded. It must be very almost like sphere, yeah, almost like sphere. You must use it because it's better to print. It's better to put this kind of shape of powder on one layer, and it's very expensive powder. The printers, the equipment is also very expensive, because they use very high power of laser. The chamber, in most cases, it must be closed chamber, but also you must use protect atmosphere. When you print something from, for example, stainless steel, authentic stainless steel, you must use protect atmosphere. For example, argon, yeah, argon, nitrogen, sometimes hydrogen, but it's very good for stainless steel, but it's not good for not environment, but it's very explosive material. That's why they use in most cases they use mix hydrogen, nitrogen, helium, hydrogen, or something like that. But for example, in our laboratory we use to sintering pure hydrogen. It's a very good quality of sintering material. The same situation is here, and also after printing you must sintering this material. Of course, I'd say that in this metal you have some kind of selective laser sintering, but sometimes you must do some heat treatment. It's good to minimize the stress of material after printing. And in more cases, you don't need any support. But for example, like you can see here, we have some supports because it's easy to remove from the table. And of course, you can use this powder again, but not to medicine. When you print something for medicine, you must use only new fresh powder. And here you have some examples of printing materials. Yeah, here some kind of thing to put on the chest, and also in automotive, and also in aeroplaning. Here we have some comparison between SLA and FDM, but you don't believe in this video, in this part of this presentation, because here is very low quality of the FDM. If you print something from FDM, you know that you can get higher precision of material. I have a lot of examples here. I can show you some examples. For example, this is very good, and I'm not sure that my camera show you the quality of these prints, but it's more better than you see on this video. But this is commercial video from internet, the company that produced the SLA printer. Yeah, that's why they must show the FDM is. Oh, this is very bad technique. Don't believe in this. But okay, it's right that the quality of surface it's much better in on SLA, not on FDM. Of course, here you have some comparing between desktop FDM, industrial FDM, but you see how you can compare on this photo these two things. Here you have complete different material, for example, and the photo is not very good quality because it's white material on white background, and you cannot compare it. Of course, you can compare this kind of prints, but you don't know what kind of basics was on this, what kind of machine settings we have here and we have here. On the first look, we see the layers, it's much higher, like in this case. And also, when you use different kind of material, and you can also smooth the material after printing. It's very easy. You must use acetone or some isopropyl, and you can smooth the material. Here you have some you see ABS, acetone smoothed, PLA. You can compare the material. Of course, when you use acetone to smooth this material, the shape it will be changed. Yeah. But in some cases, here you don't have, of course, you don't have any how it's called, any material with 100% of bronze or with 100% of carbon. This is some kind of additive to filaments, and you can get some structure. It's similar to bronze or similar to wood or similar to different kind of material, but not in 100% made from this material. Of course, for example, now the bus company sells the filament that it contain a lot of powder, metal powder. You print something on regular FDM printer. Next, you put it to furnace to remove the polymers, and next you can sintering. The shrinking range is very high because it's more or less 20%, but after regular printing, after regular FDM printing, you can get things made from solid metal, almost solid, from sintering metal. Yeah, we have some gaps between between particles. But this method is very nice. Of course, filament is very expensive because I know the Polish prices. 1,000 zlotys per kilogram. 1,000 zlotys per kilogram. It costs more or less this filament. Of course, you need to use special nozzle, but I printed on a regular bronze nozzle. The quality it was good, but you know, when you have a lot of powder metal inside the filament, the nozzle will be destroyed in very fast. Here I show you some kind of material that you can use. For example, different kind of resin, to jeweling resin, and you can use also very flexible resin. Here you have some sample used in medicine, the medical dental resin. Here you have, of course, norm what kind of material you can use in this case. Okay, and what kind of precision you can get after prints. Here you have material, some powder material that you can use even in medicine, but in most cases in medicine you can use stainless steel powder. 316, 410, 420. This is austenitic stainless steel. This is ferritic stainless steel. Of course, the austenitic stainless steel is not magnetic steel, but look the particle size, very small, and the shape is incredible around about. It's almost 100% the sphere, yeah, and that's why it's very expensive. Of course, you can use also titanium powder, but also the particles must be very small, and you must remember that when you use this kind of powder, stainless steel or titanium, they hate oxygen. No, sorry, they love oxygen. That's why we must protect it. That's why we use closed chamber, and we use a lot of protective gases, and very pure protective gases. Pure protective gases, expensive protective gases. This is simple math. Here you can see some ceramic powders, and yes, here we have some ceramic powders to make some ceramic things, and here you have this powder is called Lita bone, and it's you can use it to print artificial bone. Yeah, it's very easy to use this powder, but this also very expensive powder, because in medicine you must have very pure material, and you can use it only once. When you print something to automotive, you can use this same powder in the chamber again and again and again. In medicine, no, only once you can use it. Of course, this is a principle of how we made some prints. You must have some project, yeah, some samples. This is from SolidWorks, yeah, and you must make this structure to STL file. And STL file is format created by 3D system, of course, for 3D printing. And this is files have the form of text commands, including instruction execute in the loop. And like you can see here you see CAD model, yeah, for example, this kind of CAD model, and here you have STL model, and the quality of surface is lower, yeah, but when you want a good quality of surface, the file must be bigger, because it gets a lot of triangles. When you have a lot of triangles in this model, this is text 5, yeah. But the more triangles you get, the surface will be similar to CAD model. Of course, in some cases, you don't need a lot of triangles. You don't need a big file because it's not necessary. But if you print on very, very good quality printer, for example, when you compare, wait a moment. Okay. When you compare the prints made from Resign and when you compare the prints made by FDM, the quality it's you see the different kind of quality. Even when the layer height will be the same, the surface will be, of course, different kind of surface, different kind of quality of surface. It's very sad that you cannot be here because I want to show you some samples, and it's very easy to see by your eyes, but on computer it's not quite easy. Okay, here you have some samples, some programs that you can use to make some CAD files, and you can see here you have prices. A lot of these kind of programs are free, but for example, I use Inventor. It's program from Autodesk stable, and it's free at our university. We can use it by free to education. But also SolidWorks is very good program. But SolidWorks, Solid Edge it's Siemens. It's connected with Siemens, but you can use it to make some STL file. Of course, Mesh Mixer. Yeah, a Mesh Mixer. Of course, the Autodesk buy this program Mesh Mixer, and the quality of this program drops, but you can also use it Mesh Mixer. But I think the Mesh Mixer in most cases use it to sculpture or something like that, not to engineering stuff. More programs, and oh yes, you can also use 3D printing to print something from MRI. And here you have some examples of programs that you can use to change the MRI to STL, and in more cases are free, yeah. But it's better quality when you use to modeling some bones, because when you want to modeling some tissue, it's very hard to modeling, because you must remove a lot of artifacts after you change the MRI to STA, because you can get a lot of artifacts. Yeah, when I change for example, I scan my face, but it was only 3D scan by laser. More. Oh yes, I will. Okay, I will talk about this. Here you must also use slicer. Yeah, that I'm pretty sure that you know about that. Yeah, you must use slicer because it's you must slice the STL to layers, and you can use a slicer. I use Cura or 3D slicer, this kind of slicer. But in most cases, I use Cura, and this is very good open source slicer. But about 3D scanning and 3D printing, I scan my face and I print it, on regular 3D printer, and it's easy to combine 3D scanning and 3D printing, because after scanning you get in most cases STL file, because you get clouds of points, but the program can automatically connect these points to triangles, and you can get STL files. But in most cases, you must do very hard post processing to get good quality of prints. But on this case, you can do something like that, yeah? Scan something and print. It's they use it in a lot of techniques. They use it in automotive. They use it in medicine, of course, because when you want to modeling some connection between body and the print, it's easy. It's better to scanning and next to print some good connection. Of course, you know 3D printing. It's very easy, but you know what? Do you know what is 4D printing? Because when you print something on the printer, you get something solid, yes, like this. Yeah, it's solid. Yes, it's solid. You cannot change the shape of this. Even in this case, yes, it's also meant by on the printer. All kind of connection is made on printer. Even these joints are made from this kind of polymers. Yeah, this kind of polymers. It's very, very flexible. And when you here you have some wires, and when you wait a moment, it would be better to show you in this way. Where is zoom? Zoom. I need zoom. I want why I cannot? Sorry. I want to do something, but I'm not pretty sure why I cannot stop sharing my screen. Yes, sorry. Yeah. Now I stop sharing my screen and you see me on your screen, or yeah. Yes, here we have some printer, and this is regular 3D print. Yeah, and I told you that this joint also was printed on the printer, and when you pull this wire, you can when you pull this wire, you can change the these parts. But this is regular 3D printing. But when you can change, for example, in this case, you can change the shape of material. This is not 4D prints by itself, but the principle is the same. Yeah, you change the shape of printing elements after prints. For example, in this case, yeah, when you wait a moment, when you put it, it's open. You have some very similar mechanism, and you can open and close the box. All of these things are printed on the printer, or this kind connector. Yes, it's very simple switch, and it's easy to remove. But when you have something like that the shape change, not rapidly, but change the same. Wait a moment, because I want to open the zoom. Yeah, when it change, it's called 4D printer, because you change the shape when after printing, and you can do something like that. Yeah, here you have some two prints made by oh yeah, you see this? Yeah, you see this. I think yes. You can see some prints made by resin, and its shape change after printing. What I do here? Okay. Sorry, I have some trouble with my computer. Wait a moment, please. Jesus. Okay. Yeah, now it's quite good. Not in 100%, but more or less, because I cannot see myself on the screen, and this is not good. Oh, wait a moment, please, 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 please. Okay. No. Oh, now it's good. Sorry. Okay. Here we have two samples. Some made something from resin, and you hitting up this element, and it changed the shape. Also here, here is very interesting sample, because here you have element made from special polymers combined with ABS, and they also changed the shape. It's used. I can show you. They use it to. They use it to, for example, to. They want to do something that I will show you. Everything you can find on YouTube. It's not reserve material, and you can find some new material. You can find some information from that. Yes, this kind of polymers, and the last one, but not least, this kind of polymers. Yeah, this movie on YouTube. Yeah. Can you see this movie? This video? Yeah, as you can see. And I get it from this video. Yeah, and this is shape memory polymers, SMP. And you can also use it, for example, in medicine. But in this case, they use it to do something to buildings, to make something buildings. Yeah, it's the self-open window. When the temperature increase, I will show you here. When the temperature increase, because here we have some basics, yeah, also how they modeling, of course, how they print. Okay, as you can see, this is not very expensive printer, but with the chamber, yeah. And they use it, for example, where is the samples? Oh yeah, the modeling, and they use it to the behavior of this material. They're heating up this material, and it's open. And they want to use it to, for example, to make a building. You know, when the temperature will increase, the window will be open, self-open. Yeah, for example. And here you have some more information about SMP, shape memory polymers. For example, in hot water, you can change the shape of this material. Okay, let's previous, and the shape is back. It's very similar to shape memory metals, yeah. Okay, if you want more, you can see it on YouTube. And also here you have very interesting elements. In more case, it's basics on change the temperature, but some case it's basics on change the magnetic fields, for example. And it's easy to imagine it when you print something very small. You can put it to body, some body. You can change the magnetic field, and it will be transferred in this body, yeah, like nanobots or something like that. No, maybe not nanobots. Oh, here you have some more examples of using 3D printings to medicine. This guy have in his hand, he's not born model of here his unborn child, because they scan the child in the womb of the woman and they printing. And this photo are from England, from United States, no, Great Britain, sorry. Oh, this is not medicine printer, but this is some prints that we saw at the University of Leuven. And here you have for 3D printing corset for scoliosis, and it's print personifical. Yeah, they scan these two girls, and they print for them special construction, and of course with some special holes to ventilation the air. The heat comfort will be better in this case, of course, and it's made special for them. Yes, it's very, I think it's very nice that they can make very unique medicine, maybe not medicine, but very unique element to get to increase the health, to increase the how is it called, to increase the feelings. Yes, to increase the feelings when you can get heat treatment, because I know that this kind of construction normally are not very comfortable. That's why they use 3D printing to hide the comfort of the human. Of course, this here we have some new products that one of the company wants to make, some special pills. These pills will be faster to get when the printers will be in or pharmacy, for example. You get your medicine. You can recipe of this medicine from a doctor. You give it to pharmacy, to pharmaceutical, and it will be printing on the 3D printing. It will be printing for you, and it will be printing specially for you. It will takes less how it's called, I forgot, jeez, less material that protect this medicine from oxygen, and it will be better for your health. It will be pills for you, for example. This is a very nice sample. When you use printing to medicine, the company from United States, yeah, from University of Buffalo, they want to print these kind of elements, and they want to put some medicine inside. When you will use this protest, you will they use part of made on 3D printer for this girl to put it into her skull, because she gets some brain surgery, and they remove some part of bones from her head. That's why she must get some new one, and they use it made from titanium, plastic, and calcium. This company is very similar to previously sample. They print special for the fighters special protection on thieves. They scan their teeth, they scan the jaw, and they made protect the teeth in better way. This is very nice sample. For example, this is a nice sample. For example, in this case, you get some 3D printed prosthetic hand, and you can download the files from internet. It's open source. You can print all elements, and you can send it to Africa to children. They don't have hands, or in most cases hands. Yeah. And this is a very nice product because you can download by free, and you can modify this project. When you modify it, you can upload it, and you can say, okay, I modify it in this way. For example, it's much lighter, or it's the durability is higher, or something like that, and you can share it with everybody. It's very nice sample of using this kind of elements made on FDM printer. You can use it very easy. Here you have some kind of elements prints from the ceramics powder, and it used to rescue the life of this child. Because he's how is it called, this part? Yes, trachea splint using, yes, trachea splint. They use trachea splint because he have problem with breathing. That's why they must do some surgery, and they put some biodegradable scaffolding in here in his body. Oh, sorry. Sorry. In this case, no problem. I will remove this. Okay. In this case, this is very nice project also, and the people from United States want to surgeon, and you can print some tissue in this case. For example, at our university, we have this kind of printer, and we can use this kind of very big syringe to put some liquid material, some gel material, the construction is very easy because here we have stepper motor. Here we have, we'll open it. Yes. Here we have some parts. It also was printed on 3D printer, and it's easy to open, and you can change the piston. You can change the volume of syringe, and it's very easy. But principle of this kind of printing is the same like from the FDM. You put something inside this syringe, and you can get some 3D stuff. Of course, in this case, you must use hydrogel mixed with some kind of tissue. This is our printer. This is my photo. This is from the producer photo. And on this printer, this or different kind of printer, because of course the environment must be very clear. You can do something like that. Okay, it will be some drastic photo, but I think that you are hard and you don't have problem with that, because a few years ago in China they print some ears to these children, because these children born without ears, and they grab some tissue from them and they print some ears. Yeah, they printing using hydrogels mixed with tissue. You can download the paper about that, and they get very good effects. In most cases, it was very good. I thought that I'm pretty sure that it was 10 or 12 child, and in two cases the operation failed, and this part don't connect with the body, but in more cases it was very good. And here you see effects of that. They burn without ears, and they get. Here you have some steps of this operation, how they do this. And here you have some sample of prints of this kind of elements. It's very easy to print this kind of tissue. It's not hard now. It's problem when you want to print some more complicated tissue, but I will tell you about it. Here is some. It is some song of the future, but still it doesn't exist. They print some artificial skin, but they want to print it on the body. You know, they want to scan the wound, no, the wound, and they want to print it on the body, but it's not now. Maybe in a few years, but now they print some artificial skin on 3D printing. This is very nice example. The company Organovo, they print some very small liver. They print the liver, but it works like a liver. They works like a liver, and you can test on it because it's liver in micro scale. They can test on it some drugs and some medicines, for example. And a lot of company buy this kind of micro liver from them, and they test their drugs on this organ.
Shimon,
Yeah.
we need to finish the lecture according to the agenda. How much time do you need for?
I want to say about this, and it will be end. Okay.
Okay.
I want, because this is some Polish accent, this is some Polish accent. The medicine doctor from Warsaw, they want to print some pancreas, and this they are on the very high level of this project, because they start to test on the animals, yeah, and they print whole organ, bionic pancreas. They do some biopsy. They use cells from the patient, and they print some bionic pancreas, and they put this organ to the donator. And that's why it is very nice, because this research is on the high level. Now they started to test on animals, and they started test on humans. And maybe in the future, maybe in 1 to 5 years, we can get some pancreas prints on 3D printer. Okay, I think it's all what I want to say. And sorry that I delayed some time, but okay. Do you have some questions for me? Do you want
Tell me about low voltage techniques.
high voltage?
low voltage techniques
This.
when
This.
you introduce
The,
and talk me
oh,
about your technologies about layer by layer.
yeah. About welding. Yeah. I want.
Yeah.
Okay. I can.
Naturally.
Yes. No problem. I want to show you something, but I will open it. Yes. This kind of. Okay. For example, this kind of company. This is not that. Okay, wait. Give me a second. Give me a second. It's called, yes. It's a low voltage, but
Voltage techniques.
yeah. It's called CMT, cold metal transfer, and they can. This is welding method, yeah, and they use this method to print some elements because they can't in easy way to. For example, here you have very good example. Do you see my screen? Yeah, you see my
Yeah.
screen? Yeah.
Yeah.
For example, they use this is some commercial, but they use this technique to print something from metal, and they use, for example, here they use aluminum, but you can also use stainless steel. This is called metal transfer because when you weld, you load the voltage when the wire connect with the material, and you get for example here, sorry, this is commercial, not commercial, we don't need commercial. Wait a moment. Yes, now this technical, you see, when I open something, I open a lot of things, and yes, imaging key, and for example, they can do something like that. But the quality of the surface is not very good. The voltage is not very high because they must use um, more complicated machines than we use normal to welding. More complicated machines than we know, because when the wire connect with the surface, it must go back, and the voltage of the welding must be lower. That's why you can get very, very small drop of the liquid metal, and that's why you can do something like that. You can print something, for example, like in this case. But I told you that you see the quality of the surface is not very good, but in some cases it's only technique to do something like that. This company, this Fronius company made some part of a rocket in this way. Yeah, they print some part of the rocket, and they test it, and it was very, very good. They cannot made it in different method. They use this kind of method. It's called CMT, or low voltage welding, something like that. Okay.
Okay.
Do you want?
Nice try.
Okay, nice try. Okay.
Okay, maybe participants have questions more,
Yeah. Uh,
please.
Thank you for your lecture. I want to ask you a question. In your opinion, what is the most difficult for printing? Bone in the human body, and why for printing?
What part of it's very it's wait a moment, because some car right here. What is more difficult to print? Everything with tissue, with because sorry, it's not hard to print, for example, this kind of tissue, yeah, or this. It's not bone, but this is soft tissue. When we use one kind of cells to printing, we print some. We use one kind of cell. We mix it with hydrogels and we print it. It's not hard now, but when we print some whole organ, it's very, very tough because we must use different kind of cells. We must use blood cells. You must use skin cell or something like that. That's why when you mix material, but in all case of 3D printing, when you mix material, different kind of material, is very hard to print. Even in FDM, regular FDM, the material must be quite similar. When you print some supports with different kind, for example, with PV, you print supports, and the rest of them prints with FDM. You must use the same temperature. You must use the same maybe not speed, but the same temperature all the time. In the same principle is when you print something for medicine. When you change the material, when you change the mix, when you mix the material, it's hard to printing because the material cannot. They want to connect. Yeah, they want it to connect. That's why you must use. It's very hard to use. When you print something, for example, like some kind of elements to make some parts to replace the bones or something like that, it's not very hard to print, but you must use very good quality of materials. I told you about the powder material, the small particles, the spherical of shape you must use, and it's very the cost is very high because you must use it only once. You cannot use it again. You can use it the same powder when you print it. In different kind of techniques, you can use it. The technique, but different kind of industry. You can use it, for example, to automotive. And when you have left the powder left for you, you can use it again. In the medicine, you can use it only once, and you must maybe not throw away because you can use it in another way, but the cost is very high. Do you want to know? Do you want more or something like that, or it's good? Nice kid.
Thanks for your answer.
Okay.
Yeah. Thank you. More question? No more questions. Thanks to Shimon for an interesting overview lecture.
Thank you very much.
Then we finish the first lecture today. Yeah, maybe someone wants to say a few words, participants? No? Okay. The next lecture will take place at 13 o'clock in Ukrainian time. See you later. Lecture conduct Galina Tabunchik from Zaporizhia National Polytechnic University.
Okay. Thank you very much.
Thank you. Galina. Galina, are you here? We need to wait in some minutes. Okay. Peter, I'm glad to see you.
Hi, good morning, everybody. Yeah, Galina was there. I saw her in the list, but now she disappeared, it seems. She was on page 2 of the attendance list, but she's not there, so I don't know.
Okay, I call to Galina. Galina?
I see her.
Okay. It is my pleasure to introduce Galina Tabunchik. She is a professor from National University Zaporizhia Polytechnic, and she is also the coordinator of the BIOART project at Ukraine. Galina, please start.
Hello to everyone. Hello, Alexander. And it is very interesting that today's my lecture deals with reliability, and it was very reliable when you told that you want to introduce me, and my internet failed at this moment. This is what we will talk today. What is a reliable system? What is safe systems? And what threats are we meet in medical devices? So I will share my screen. So the title, which is in the agenda, is Quality of the Medical IoT Systems. And first, I want quickly to introduce myself. As Alexander already told, I'm professor of software tools department of National University Zaporizhia Polytechnic, and I'm teaching everything what is deal with software modeling, design, testing, and development. I have a small research group with my PhD students, and the other part of my work is coordinating of international projects, and it is Key Action 2 projects such as BIOART and Key Action 1 projects with our partner universities. Within our BIOART project, our team consists from 3 different departments, and we already accredited new master curricula where I'm teaching 3 disciplines, but today I will present you material which is connected to the 2 disciplines which is in our plan. It is the medical informational systems and project management, regulation, standardization in the medical sector. So this is shortly, and I would ask you to introduce yourself. I also want to know who is my audience. Could you please go to the site menti.com, put the voting code, and we will try.
Please give us a QR code.
QR code was, you could see this is www.menti.com. Yes, and the code you could put there is at the top of the screen, 79 51 95 79.
Can you send this text to the chat?
Yes, I can.
Thank you.
strange. I can't vote. I'm also trying to do it with you. One moment. I suppose nobody complained, but generally I just got on my telephone that this
It's
question is
closed.
yes, it's closed for voting, and for me it's a very new type of a problem. Yes, so yes, it is. Yes, and white is closed. Yes, it is closed and white is closed. One moment. Mhm. Anybody could help me why it is closed?
The presenter should open it.
Yes, I can understand. Now
Oh,
I
yes.
suppose so. We won. So now you have you can put any word which you know about quality. And thank you. Quality process, quality systems, yes. Best or the best. So 5 people already tried to safety. Very good. So some people more want to work. Only 6 people from 46. Someone else ready to write some words which are connected with quality. Must have, yes. Quality must have, but not always. And maybe someone else wants to participate in this great challenge add some words about what do you think, what words?
Explain, please, again, what should we do right now?
You just, if you have any, what words in your mind are connected with quality? Just like brainstorm. What is first appear in your mind when you think about the word quality? So our cloud of words is a little growing. And you see in the center is more common is reliability. Okay, thank you very much. And already 12 people connected to this questionnaire. And the second question is, please. Just introduce yourself, who you are, bachelor, master, PhD student, or just like my colleague from other university. So colleagues are always more active. Nice to see students, bachelor students here, and masters. So half of the active participants are my colleagues. I'm very happy that they are here and active, and happy to see that there are bachelor students, active bachelor students. It's really appreciating that you're still active and want to learn more. So thank you very much for your answers. So now to third students, which was the aim of this pilot teaching, that we are teaching for our students. And what is our plan for today? I will shortly go from the types of biomedical applications which are exist, and then we will go for the main definitions connected to the dependability of the IoT systems and its attributes. And in the end, like quickly overview of techniques which are used for modeling of the dependability of our biomedical applications. So different biomedical applications could be classified in different ways. It could be classified from the point of view of stakeholder. Yes, it could be IoT applications for patients, such as wearable devices. It could be IoT applications for physicians. Yes, for rehabilitation services. It could be different IoT applications for hospitals, for monitoring patients' health, and a lot of different medical equipment, such as wheelchairs, defibrillators, oxygen pumps, and even yesterday I received in the journal Spectrum from IEEE that they are going to make these electronic injections with the vaccinations. It is now a new trend, so it's a lot of very useful devices, and there are IoT for health insurance companies, yes, which allows to monitor and proceed data. From the other side, we could divide biomedical applications from the point of view of architecture, yes, and the main technologies which are used there. So it could be like applications for biomedical sensors. It could be hybrid systems involving microfabrications and living organism, and it could be data mining applications with the usage of data for classifications and machine learning methods. It is for text mining, learning terrain, and many others data mining applications. What is important to keep in mind, it is the architecture of IoT systems, and generally architecture of medical IoT system is generally the same as any IoT systems. It is like you can see a four-level architecture, where information from the devices moving to the data aggregation and preprocessing, and further going to the data storage level, and the fourth level, it's application level, yes, which is used for data analysis and different others applications. And what is very important in biomedical applications, that it is critical applications. This is applications with a high level of risk and great consequences, which influence on the society, on the patient health in the end. And we can see that generally each stage of our IoT application contains a variety of risk factors which could cause problems, and which could cause effect on the patient health. For example, yes, we can see from this table that, for example, at the data level and application, the risk factor when we need to do manual data. And there are a lot of there are high risks of losing data, and a very important issue of losing of data privacy, and the attacks on server security, yes, and on clinics servers, on infrastructure. The great problem of any medical application is latency. So when we have, so it is very important to always consider these risks, that our middleware sensors applications have delays and slow working, and this is also risks for our IoT medical applications, yes. And additionally, we shouldn't forgot about network environment and financial risks, which also deals with our biomedical applications. That's why considering all these risks, it is very important to have tools which will help us to reach dependability of our biomedical system. And first of all, we will look at the term dependability from the point of view of system, not concretely of IoT or something like this, from this system. And dependability of a system reflects the user's degree of trust in that system. It reflects the extent of the user's confidence that it will operate as users expect and that it will not fail in normal use. Dependability covers such systems attributes as reliability, availability, and security. And we will look at it one by one. Also, you will see that considering this 4-layer architecture of IoT systems, the main issues of the dependability of medical and general IoT systems is mainly located for the IoT devices and networks connection, because it is the first data which is which is base for all further level of our IoT system. The main term which you should understand, it is failure. What is failure? Failure is a disruption of the ability of a functional unit to perform a required function. Meanwhile, you can see from the chart that failure not always brings system to incorrect or hazard functioning. When in the system appear failure, the system could continue functioning, but system is still available, and you could manage with these failures. So you identify that it exists, yes, you take some some repair, for example, and then your system return to the correct state, yes. And but there are other types of failure which could bring your system in incorrect and not working system. The other term which is difference, yes, it is error. Error is an internal consequence of a fault during the implementation of the product. It may be the subject to defects related to design, verification of defects, defective usage, defects in maintaining the system in operational conditions, and etc. As you can see from the picture, I hope you could see that at a different level, from the device level to the mid-level and application level, there are a lot of threats which is meet our IoT related systems in healthcare. So let's summarize what are faults and what are failures. So failures are usually a result of a system error that derives from faults in the system. Faults do not necessarily result in system errors. and errors do not necessarily lead to the system failures. There are 3 causes of the failures. It could be hardware failure, it could be software failure, and operational failure. Hardware fails mainly because of the design and manufacturing errors, or because the components have reached the end of their natural lifetime. Software failures usually appears due to error in their specification, design, and implementation. And operational failure is often a result of human mistakes. From the other side, faults could be classified as permanent faults. They persist indefinitely after their occurrence. Intermittent faults, they occurred sporadically, and transient faults. They occurred in isolation, such as, for example, electromagnetic interference. To deal with the faults, you could choose one of these 4 approaches. It could be fault prevention, it could be faults elimination, it could be a fault tolerance, and also fault prediction. Let's check what you have understand from this first introduction into terminology. I put code in the chat.
Please open it.
It still can't be voted.
It's okay now. It's okay now.
Okay.
Excuse me. Tell me, please, should we enter our full name or just name?
Just any nickname you want. It's not recording anywhere. It's just for you to check if you catch the difference between faults, failures, errors. It's not for mock. And is it is you're located through all Ukraine? Yes, I suppose there are students from all our partner universities. So I can't promise you present as Albert did. Okay, 12. Oh, we have 1 million person more.
We are waiting when it starts.
Okay, so the ability to estimate the presence, creation, and consequences of the fault. Is it fault prevention, fault elimination, fault tolerance, or fault prediction? And it's fault prediction. Only one person gave correct answer. We have one leader at our leaderboard. And now let's go to the only 6 person left to the next question. These faults persist indefinitely after their occurrence. Transient faults, intermittent faults, and permanent faults. Much better. So let's see. Our leaderboard. What is nice that this in these questionnaires, the dynamically changing leaderboard, and we have very strong leader. And let's go to our final question. Not good as the second question, but better than the first. So the subject of defect related to design, it is error. And what will tell our leaderboard? But our leader is the same. So our congratulations for Andrei. And let's continue. So with the system dependability has 5 main attributes. Availability, it's the ability of the system to deliver services when requested. Reliability, the ability of the system to deliver services as specified. Safety, the ability of the system to operate without catastrophic failure. Security, the ability of the system to protect itself against deliberate or accidental intrusion. And resilience, it's the ability of the system to resist the cover and cover from damaging events. So, and now we will look at what is common in these attributes in definition and what is different one by one. So, safe system operations depends on the system being available and operating reliably. A system may be unreliable because of its data had been corrupted or any external attack. And also these attacks on the systems are intended to make it unavailable. So if system is infected with virus, it cannot be confident in its reliability and safety. Looking at the IoT systems, there were considered this RAMS approach. And you can see that additionally, there were additional attributes such as integrity, confidentiality, and maintainability. And all these attributes are deals with dependability, and the first 5 are deals with security of the IoT systems. So our attributes, what are their sense? Availability is a readiness for correct services. Reliability is a continuity of correct services. Safety is an absence of catastrophic consequences for the user and the environment. Integrity is an absence of improper system alterations, and maintainability is the ability for modifications and repairs. From the other side, so how we can look at these attributes. Reliability is continuity of the operation state during some time. Durability is continuity of operations with periodic maintenance and repairs until retirement time. And maintainability is an ability to support operation state to turn back to operation state after periodic maintenance and repairs. And storability is an ability to support all dependability attributes during storage. So dependability is described by these system attributes, as we already looked, yes, availability, reliability, safety, and security. Reliability is related to the probability of an error occurring in operational use. System with known faults may be reliable. Safety is a system attribute that reflects the system's ability to operate without threatening people or environment. And security is a system attribute that reflects the system ability to protect itself from external attacks. To achieve dependability, what we could do, we should try to avoid the introduction of accidental errors in the design of the system. We should pay attention to verification and validation processes. We should design protection mechanism that guard against external attack. We should configure our system correctly, and we should always have a recovery mechanism which will help us to restore our system to normal state after failure. So when we are talking about quality, when we are talking about dependability, we all know that costs are increasing exponentially, and earlier you find errors, yes, less costs of our systems. And what is very important for our medical IoT system, as I was already telling that it is critical system, they should be it should contain redundancy, and our coverage. So we should understand that the coverage should be 100% for our testing as well. So yes, this is those systems that when usually price of testing, so price of verification and validation usually much higher than the cost of our system. So the final voting for today, and I will not disturb you with the Mentimeter more. Sorry. Let's wait a few minutes, 1 minute more. Yes, it was a little more people previous. Have quorum. Let's go. So the probability that the system will be up and running and able to deliver useful services to user, it is availability. We have a leader. Understand. Sorry. Okay. Well, I suppose this is very easy. Yes, it is maintainability. The leaderboard is keeping the same. And let's go to the final question. This is reliability. And we have a new leader by the end of the questionnaire, and our congratulations. So continue for our attributes. Availability and reliability. Reliability is the probability of failure-free system operation over a specified time in a given environment for a given purpose. Availability is the probability that system at a point in time will be operational and able to deliver the requested services. Both of these attributes can be expressed quantitatively, and availability of 0.99 means that system is up and running for 99% of time. If it is possible to subsume system availability under system reliability, yes, as if system is unavailable, it can't deliver the specified services of the system. But from the other side, systems with low reliability could be available. That's why these terms are not replace each other. And that's why availability is better to consider as separate attributes. From also for reliability, so this system reliability and user attitude to reliability are not usually the same. And this is also like you should keep in mind that formal definition of reliability sometimes not reflects users' expectations from a system reliability. And that's why we should also look at this term from the point, so from different point of view when we try to give these estimations. From the system point of view, reliability could be defined with respect to the system specification. And as we always knew, that that is a very common situation, that specifications are not complete, and that's why we can't understand from them or why the system fail. And that's gives user low expectation from the terms of reliability. Availability is specified as a percent of time when system is available and deliver services. But also, you should always keep in mind that number of users which are using the system and the length of this outage. So, for example, look, your system could be available 99% of time, yes, but this like 20, so when we're looking at like remote any system, 20, you're expecting that it will work 24 hours, 7 days per week. But we usually know that maximum load of the system is within, for example, from 9 a.m. to 10 a.m. So most of the users are using your system within this period of time. And if at this time your system will be unavailable, generally your system is not reliable. Yes, this is the time when your system are mostly used. And in the end, yes, but if you will look only at the term that it was functioning all 23 hours other, yes, when there are no users for your system. So from the point of view, availability is very nice. But from the point of view of users and from the functioning of the system, it's not so, yes, because the system was unavailable when the most of the users were trying to work with this system at this period of time. So that's why be very careful to this moment when you use availability as an attribute to describe dependability of your system. When we are talking about reliability, we always, so we usually deals with such terms as human error. Yes, when human behavior results in introduction defaults of the system. System error, when software system leads to the system error. System fault. System error, it's when the behavior of the system is unexpected from the point of view of users. And system failure, the event that occurs at some point in time when system does not deliver a service as expected by its users. When we're talking about reliability in use, we should understand that generally not all faults, not all defects resulted, so cause the problem in the final functionality of the system. And as you can see from the IBM research that removing 60% of product defects results only in 3% improvement in reliability. That's why you should also, when you are talking about general system, you should always take it in consideration, but it's not really important when we are talking about biomedical system, when we are expecting that there should be 100% reliability, yes, and we should remove all faults not to bring harms to our patients. To also to work with reliability, yes, to achieve reliability, we have these three approach, which we already mentioned before. Yes, it is fault avoidance, fault detection and removal, and fault tolerance. Yes, when you accept the tolerance for your system. If we will look to IoT reliability, we could divide it into our layers, as you can see. So when we're talking about IoT before we were talking about system reliability generally, a system. Now we are talking about IoT applications. So in these cases, we are talking about device reliability, communication and network reliability, and reliability of the application level. The most important, as I was telling in the beginning of my lecture, it is for IoT system, it is device reliability, and it mainly deals with the constraints of the devices. And these constraints are battery, yes, it's memory, and computational capacity. And the other element, which is very important to the device reliability, it is environment conditions where your devices are functioning, because on its reliability, it could be is influencing heat, temperature, mechanical vibration, and other external environment factors. And the third element, which deals with the device reliability, it's false reading. It's a common problem of a lot of devices, and when devices are working, are not working correctly, but generating numerous of fault data, and generally your system received this data, system can't recognize that device is not functioning, so they can't recognize error, yes, as the device is generating this data, but this is false data, and this cause for incorrect interpretation and incorrect decision making in the end. So it is a very big problem, and it exists, and generally there are a lot of publications which are deals how to deal with this error. The other important moment for IoT reliability, it is a communication and network reliability. Generally all studies which are deals with this layer could be divided into two parts. Yes, it is one which are deals with the quality of services in networks, and the other is deals with the quantifying reliability metrics of the networks. And when we are talking about application layer reliability, yes, so we're talking about software and reliability of the software systems. So the other attribute is safety. Safety is a property of system that reflects the system's ability to operate normally or abnormally without danger of causing human injury or death, and without damage of the system's environment. And for biomedical system, it is a very important attribute. We already discussed it many times. And medical IoT system, it is primary safety critical systems. If to look at safety and reliability, something is talking with me. Okay, I still have 20 minutes. If we are talking about safety and reliability, they are related but distant. Reliability is concerned with the specification and functioning of the service, but safety is concerned with ensuring that systems cannot cause damage, which is with the bytes functionality. It could happen so that reliable systems could be very unsafe, and please don't forget it when you design your IoT biomedical systems. How we could achieve safety? It could be achieved by hazard avoidance, by hazard detection and removal, and by damage limitation. What I want you to tell further. Okay, security. I thought that I have example will be later. Security. The security of a system is a system property that reflects the system ability to protect itself from accidental or deliverable external attack. Security is essential as most systems. So we have connected systems, yes, our IoT system, and that's why nowadays the cybersecurity is one of the essential points for the medical IoT devices. So what we should tell that insecure systems are unreliable, but reliable systems could be insecure. So this is if your system is insecure, generally your reliability and safety are no longer valid. When we are talking about security terminology, we are usually using such terms as asset, something of value which has to be protected, exposure, the possible loss or harm to a computer system. Vulnerability is a weakness in a computer-based system that may be exploited to cause loss or harm. Attack, an exploitation of a system's vulnerability. Threats, circumstances that have potential to cause loss or harm. And control, a protective measure that reduces the system's vulnerability. If we will see this slide, you could see example of secure terminology. Yes, and which is deals with healthcare and patients, individual patients record as well. So an example of asset in this case, it is the record of which patient that is received or has received treatment. Exposure, it is a potential financial loss from future patients who do not seek treatment because they do not trust the clinic to maintain their data. Vulnerability is a weak password which makes it easy for users to get guessable passwords. Attack, it's an impersonalization of an authorized user. Threat is an unauthorized user will gain access to this system by guessing the credentials. and control. It is a password checking system that disallowed user password that are proper names or words that are normally included in a dictionary. Treats. Treats classes could be divided all treats could be divided into three main classes. Treats to the confidentiality of the system, treats to the integrity of the system, and treats to the availability of the systems. Damage. Damage from insecurity could be because of denial of services, because of corruption of programs or data, or because of disclosure of confidential information. From the point of view of European organization in reliability and system, they made a survey and they selected the main critical assets for a health, and they are now depicted on the slides. It is so that is the most critical assets. It is health informational systems, it is clinical data repositories, it is authentication server, it is laboratory informational system, it is radiology informational system, it is picture archiving and communication systems, it is electronic health record components, it is patient health record service, and it is electronic prescription services. At this slide, you could look for this electronic healthcare record system, the examples of assets and their impact in case of failure. To assurance security, there are again three approach. Yes, it is avoidance, elimination, attack detection and elimination, and exposure limitation and recovery. So you could see that from the point of view also after investigation, there was selected the most critical security challenges, and you can see the first four are system availability, lack of interoperability, access control and authorization, and data integrity. And also there was also questionnaires, the security objectives and their priorities, and you could see that the highest is physical and environmental security. It's all the first priorities nowadays. All standards in healthcare could be healthcare applications, could be divided into two parts. It's specific healthcare standards and general secure standards for informational systems and automation. From the following slides, I will not name them. Generally, we don't have time for it, but you could have, if you are interested, you could take this presentation. It is all here. So, for example, on this slide, you can see a set of cybersecurity standards for medical devices. And here you can see the a set of standards. Yes. So from the point of view of the life cycle, these standards distributions. In USA, they have a set of national standard in health security and health security. Generally, this is all what I wanted you to tell. Just to finalize for you for further, maybe if you are interested and looking what you could further do for your work in your project thesis, in your master thesis, in your bachelor thesis. Yes, what techniques you can use for assessing dependability. Yes, and modeling dependability. For this purpose, you can use these techniques which are now depicted on the slides. So the most commonly used are reliability blocks diagrams, fault tree analysis, and reliability block diagram, Markov chains, and model checking. So these 4 techniques are the mostly common used in the sense of achieving dependability, so to achieving the user trust for your biomedical system. So this is to be in time. I will finish 5 minutes earlier. Maybe you have some questions I could answer you.
Tell me more about security system.
What more you want?
About security system.
So to achieve security, to improve security, I already showed you of your IoT system. There are also, you can use as a hardware approach, as a software approach, and generally it depends, as usual, from money and for the approaches. Yes, to reach the required level of security. It's also not sounds very good. Yes, but we can't. So we should make always assumption that our system is secure. So you could use as hardware protection for your system or software, and all this could be the aimed to avoid vulnerability as it is depicted in this slide. This means that vulnerability because of your actions, because of your introduction of some encryption algorithms or something like additional hardware encryption for your system. This vulnerability will not occur. Or for example, you will add some software which will detect your DOS attacks on your system, yes, and quickly switch off or block it. So this is attack detection and elimination. Yes, or in the end, you should always have this protection mechanism that if your system cannot deal with the attack, you could recover it. So you should have a possibility to recover your system. But for example, like for heart implant, it is impossible. Yes, if your heart implant will stop functioning because of attack, it is difficult, I suppose, to restore human heart to work again. Yes, and that's why all your actions should consider the final harm to the people.
You said that it's for rich people. What should we do if already poor?
I'm not very clear the question.
You said only rich people can afford this.
What rich people can afford?
Security assurance.
No, I didn't tell this.
And you said that rich people can afford something.
No, I told nothing about rich or poor people. I was telling about I was telling about system. I completely never talked about rich or poor people. I was talking about system, about dependability of the medical system, biomedical systems. We're not talking about rich or poor people. Okay. So any system which is designed, it should be reliable, available, secure, and safe. And I told in the beginning that all biomedical systems, it is critical systems, and that these systems should contains redundancy in its design, in its testing, and its verification.
It's clear for me.
Okay, maybe the participants have questions more.
I have some question. I want to ask you. Thank you for the lecture. I want to ask you. There is an opinion that the protected system is one that is more expensive to hack than profit. What do you tell about the medical system about it?
I already told about it that yes, so for biomedical systems, so when we design biomedical system, we should always understand that this system should be tested. So generally, when we design like any software system, yes, so we usually define what test coverage will be more acceptable in this or that case. Yes, so we never made like 100 coverage from the first of all because of these costs. Yes, so cost of testing verification shouldn't be more expensive than the design as well, but this can't be considered for a biomedical system. For biomedical system, it is quite so. Biomedical and space systems generally, these systems, the part for the testing, verification, and validation is much more expensive than their design. So this is it, and we can't do anything with it.
Okay, thank you.
Okay, more questions? No questions. Maybe someone wants to say a few words for discussion, reports. No. Thanks to Galina for interesting with interactive elements lecture.
My pleasure.
Okay, we finish today pilot teaching, pilot day. Pilot teaching day. Thank you all for your participation, and tomorrow we will start at 11 o'clock according to the schedule agenda. Maybe you turn on your cameras to make a screenshot with participants' second lecture participants. Well, thank you. David, good day.
Hello, Alexander. Thank you, Galina, for the lecture.
My pleasure.
Okay. The most active participants. Okay, thank you. Thank you very much. Have a nice day, everyone. See you tomorrow.
Have a nice day. See you tomorrow.
Goodbye.
Bye.
Tomorrow, bye.
Goodbye.